All right, so we've been talking about these inequalities. We talked about absolute value. Now what we're going to do is we're going to merge them and talk about absolute value inequalities. Okay. Like I said yesterday, I believe this is to be one of the more difficult things to work with. I'll try to simplify it as much as we can, but there's some rules that we need to remember when we address these. Okay. It says absolute value inequalities can be written as what we call compound inequalities, using the words and, or. Okay. In mathematics, when we talk about, especially with absolute value inequalities and just inequalities in general, the word and refers to the idea that solutions satisfy both original statements. The word or means solutions satisfy one or the other original statement. Okay? That's what we're talking about when we see the words and or inside these inequalities. Okay? When we talk about a absolute value inequality, here it says the inequality, which is the absolute value of x, is less than 2. Okay? It says it represents the distance between x, our solutions, and 0. Okay? That is a distance less than 2. Okay? So x is our solutions, right? Okay. When we talk about absolute value, we talk about the idea if this is an absolute value equation. We said the absolute value of x is equal to 2. We said that could have put me a distance from 0, 2 units to the right of 0, or 2 units to the left of 0. Correct? You guys remember that? So if I had, let's just kind of draw that out here real quick. Because just like other inequalities, absolute value inequalities, if I know where we are equal, I should know then where we are unequal and where we have our solutions for our inequalities. So if I looked at this, you guys remember the other day we said, okay, if I have absolute value of x equals 2, then that really means that x could be 2 or x could be negative 2, right? You guys remember doing that? So I could be there, or I could be there. Okay? That's if I'm just talking about being equal to 2. But now it says that absolute value is less than 2. So now the distance from 0 is less than 2 units. Well, if I'm starting at 0, right here, would you agree that if I'm standing right there, that I would be less than 2 units away from 0? Does that make sense? If I'm standing right there, would I be less than 2 units from 0? If I'm standing there, would I be less than 2 units from 0? Does that make sense to everybody? So as long as I'm standing anywhere in that region right there, I'd be less than 2 units away from 0. Questions on that? Okay. But I could also be 2 units less than or a distance less than 2 units from 0 if I was standing there, or standing there, or standing there. Okay, that distance right there where my cursor is less than 2 units away from 0. So it should be a solution to my inequality, this yellow inequality here. So we're going to be talking about all of this stuff that's in red as well. So all that stuff that's red and all that stuff is black would be solutions for that absolute value inequality. Does that make sense? Okay. So when I ask those questions and I get silence, I'm going to assume that silence means yes. Okay. If we look at the next one, it says, whereas the inequality, the absolute value of x is greater than 2, That represents the distance between x and 0 that is greater than the value 2, or a distance of 2. So again, if I said the absolute value of x was equal to 2, that would yield x equals 2 and x equals negative 2. That would be the starting points. Okay, that's the exact distance of 2 away from 0 on either side of 0. But the inequality says that the absolute value is bigger than 2. Well, if you're standing at 3, if you're standing right here at 3, would you be more than 2 units away from 0? Does that make sense? If you're standing anywhere over there, at 4, or 5, or 2.5, or 2.1, all of these markings over here all represent distances that are more than 2 units away from 0, and that's what we're asking here. Okay? But why do we have these over here? Because distance from 0 can be expressed over here as well. That is, if I'm standing at negative 4, I got to walk 4 units to get to 0, right? Well, that's more than 2 units. So I have to have these solutions over here on the left-hand side as well. Okay? That is the logic behind the procedures that we're going to go through here in a moment. Okay? People always ask, well, why do I have to do what you're showing me, what these steps that I have to do? It's because if we don't, we'll only get maybe those answers. Okay? Or that half of answers. But we also need the idea of working to the left of 0, so we need that solution and that set of solutions. Does that kind of make sense, everybody? So that's why I'm going to give you 2 rules here when we see these problems. Okay? So I'll skip this for now. We might come back to that here in a moment. But it says, in general, the following is how you set up work to solve absolute value inequalities. Okay? You're going to have one of 2 types of inequalities. You might have a less than inequality, and you might have a greater than inequality. You have to pay attention to that because it's different rules per inequality. Okay? Says that red one says if absolute value of some A, some expression, is less than B, then we write the negative B is less than A is less than B. Okay, and then we solve that. Okay, we worked on solving that a couple days ago. All right, what that's going to do, if you remember what this meant, what that picture meant right there, okay, that's a between statement. That means our variable term A is between negative B and B. So what that would give me in a graph would be something like this graph right here, where our solutions are between negative 2 and 2. Okay? So that's a between statement. That's an and statement. And we can only write that if our problem looks like that first. Okay? If our problem uses a greater than sign, okay, then that means our variable term is going to be more than B units away from 0. So this is going to give me essentially the solutions that look like this right here, bigger than a distance away from 0. And we then write the word or, and we come up with this other phrase here, which is our variable less than negative B, which is then going to produce these solutions here in this type of image. Okay, so those are the 2 rules that we're going to abide by. Okay, when we say the word or, it says the or does not mean you get to choose which one to do. You need to do both and incorporate or in your final solution or answer. Okay, so you must have the inequality written with the absolute value of A coming first before you can make the compound inequalities from steps 1 and 2 here. Okay. We need to make sure that our particular problem looks like the if part in the red and blue phrases up there before we go ahead and conclude the then part in these red and blue phrases. Okay, so what I want to do is just make a couple of examples. We'll run through a handful of examples here, and then if you have questions, you can answer those questions, and I'll set you free on some stuff to work on. All right, so this example here, and I'm actually going to, let's see if I can cut and paste real quick. Let's make things a little bit easier. Let's do it this way. Okay. So if we look at this problem here, okay, is the absolute value, is it isolated like it was in these two things up here? Is the absolute value by itself? It is. It is. That A, we can have a lot of stuff inside, but you look at is there a bar, and then those are the beginning and ending of the left-hand side. There you got a bar, and they're the left and the right of the left-hand side. Does that make sense? Or beginning and end of the left-hand side. So we do have that there. Now, what kind of symbol, what kind of inequality symbol do we have? Less than, okay? So what that means then is that we currently, our problem right there is matching this red phrase, right? So if I want to be able to solve this, then it says you then write this right here with your specific problem. Well, look, capital A was the thing that was inside the absolute value bars, right? So what's inside our absolute value bars? X plus 3. Okay. You then use the inequality sign that is being used here. So it's less than. Okay. You just got to pay attention to it. It's always going to be, in this situation, always going to be less than, but it might be less than or equal to. So you got to make sure that you have the equality part if it's present. And then it says your B term. So B, what would our B, what would this be right here be for our problem? You guys agree that's 5? Does that make sense? Okay. So they're saying you put 5 there, you put the opposite of 5 right there. And now that generates something that we talked about in section 1.5. We should be able to solve that by subtracting 3 from all 3 parts. And I get negative 8 is less than X is less than 2, right? Does that make sense? And now we graph it. So on my graph of negative 8, I have 2. What kind of dots should I use if we're using these symbols of less than? Are they open dots or are they closed dots? Open dots. So open dot at 8 or negative 8, open dot at 2. And because X is between in this statement, then I'm going to shade between on my graph. And now think about what these solutions mean. That means any number I pick out between negative 8 and 2, when I plug back in for X, it should give me a true statement. Okay? So if I plug in, let's say 0. 0 is in here, right? Plug 0 in here. If I plug 0 in for that absolute value of X plus 3, what's 0 plus 3? 3. What's the absolute value of 3? 3. Is 3 less than 5? Yeah. Okay. If I plug in 1, I'm going to get 4 here, right? Is the absolute value of 4 4? Is 4 less than 5? Yeah, and that's why these are shaded, is because they're representing our solutions. If we just quickly look at doing this on Desmos real quick. I'm just going to type in the absolute value of A plus 3, and then what was the other side was 5, wasn't it? 5, and I want to look at less than. So let's say I can set this bottom value to be negative 8, and I can set this bottom or top value to be 2, And if I play this and stop at any time, this left-hand side, this number right here, will always be smaller than 5. No matter what I do, smaller than 5, no matter where, correct? Does that make sense to everybody? Okay. But once I make it, let's say that this goes from like 2 to 10. Now do you see that that number is actually bigger than 5? Is that okay with everybody? And it's always going to be bigger than 5 from 2 to any number over here, because those are numbers that we didn't graph, right? So any number that we did not graph over here makes this statement actually false. Okay. Can we do that? One thing I want to make sure that we're able to understand is that, one, can you do the procedures, but two, do you know what they mean when you're done? Okay. And I think that's something that gets overlooked a lot. I can be a robot and do step 1, step 2, step 3, step 4 every single time, but do I know why I'm doing those things, and do I know what the end result is actually telling me? Okay. If I look at this one, is the absolute value all by itself? Like both our if statements down there at the bottom, right? Okay, it's by itself. Okay, is it the red one or is it the blue one that we're going to use here, though? Which one does this phrase model? Does it model the top one, or does it model this one? It's this one, right? Okay, because we've got the absolute values both on the left. That's a greater than sign. That's a greater than sign. So all I need to do then, if that's the case, is I figure out, okay, well then that means you have to write these two things right here. Okay, so the way I've wrote this, what is our capital A for this particular problem? Y plus 8. So I say y plus 8, and then I use the greater than sign. But now just pay attention, because ours is greater than or equal to, right? But I use that, and then what is our B for our problem? 3. Okay. Then I write the word or. And again, you've already told me what A was. A was our y plus 8. Now it says use a less than sign. We just got to remember that ours included equality as well. And then you said B was 3 for us, right? So this is saying make it negative, so put negative 3. Does that make sense? And now we can solve for y. So I'll subtract 8 here. So we get y is greater than or equal to negative 5. Or subtract 8 here. We get y is less than or equal to negative 11. So I'm going to find those two spots on the number line. Negative 11. Negative 5. It says y is greater than or equal to negative 5. So greater than or equal to is a closed dot, right? And numbers that are greater than negative 5 should be to the right. Okay, so that's those values. And then I'll do the other one in blue. So y is less than or equal to negative 11. Closed dot at negative 11. And numbers that are less than negative 11 are shaded to the left. And that idea says that now if I choose a number that is in either of those red or blue regions on my graph, when I plug back into the original inequality, I should get a number that is more than 3 inside that absolute value, or a number that is less than negative 3 in that absolute value. Does that make sense? So give me a number that's in that red region. Negative 2, okay? So let's plug negative 2 in. If I plug negative 2 in here, I get negative 2 plus 8 is 6, right? 6 is a number as the absolute value that is more than 3 units away from 0, isn't it? That makes sense to everybody? So numbers that show up here are going to make this quantity, this amount, more than 3 units away from 0. Okay? If I plug in, let's pick a number out of the blue. Okay? What would be a number that's in that blue that's more than negative 11 or negative 13? So negative 13 plus 8 gives me negative 5, right? Okay, negative 13 plus 8 gives me negative 5. Is the absolute value of negative 5 more than 3 units from 0? So the absolute value of negative 5 is 5, right? Is 5 more than 3 units from 0? That make sense? Okay. So whenever you see an or, I don't want to say every time, but 99.99% of the time, when you see an or statement, your answers are going to be graphed kind of like that, where they're going in both directions. Okay, and there's a gap in the middle. If you see an and statement, like what we have up here, okay, 99% of the time, your answer is going to look like this, where you've got shaded in between your endpoints. I want you guys to take a minute on your own and do this next one. Absolute value of 2v minus 1 less than or equal to 9. Take a minute and do that. You can work with one another, ask each other questions, and then we'll reconvene and talk about that solution. So which one does this model? Does it model the top one, or does it model the bottom one? They're all, it's the top one, isn't it? The red one? Because I've got my absolute value isolated. It's a less than sign. It's a less than sign. That's a less than sign. So we're going to write our inequality this way. Okay? So you'll hear me say the phrase, I get rid of the absolute value bars, and that gives me really that side of the inequality that I need. So I get rid of the absolute value bars, and then I come over here and I put the opposite of whatever that number was. But that generates what I've got circled there in the red phrase, the opposite of your B, less than or equal to your expression, okay, less than or equal then to the positive B. So if I'm going to solve this, what are you going to do first? Okay. So I'm going to get negative 8, less than or equal to 2v, less than or equal to 10. Then what are you going to do? All right, so divide by 2. I get negative 4, less than or equal to v, less than or equal to 5, right? And now you graph it. So because of the way that this is structured, v is between negative 4 and 5, right? So if that's negative 4, if that's 5, our solutions are going to be, we include negative 4 and 5, shade those in, but now our solutions are going to be all of those between. Once you guys have that down, go ahead and do the next one. So absolute value greater than 28, right? So greater than, so an absolute value of greater than something would be this bottom one, right? So they're going to rewrite this as our A. What would our A be for our problem? Remember, A is the thing that's inside the absolute value, right? This would be 3D minus 7. We say that is greater than B. Then we write the word or, and we do the same thing, 3D minus 7. And then we use the less than sign and the opposite of B. something I always, and in my mind, the way I remember my rules is if it's greater than, the two equations I come up with are the original. So if I look at this statement here, is this the exact same thing? I just got rid of the absolute value bars. Does that kind of make sense? So I always tell myself, when it's greater than, you just do what is there without the absolute value bars. But I always remind myself, well, I can't just get rid of something and something not take its place. So when I got rid of the absolute value bars, I know that that is going to make me generate this second inequality, which is exactly the same thing, except for I flip the inequality symbol and I flip the number at the end. I make it negative instead of the positive that it started with. Okay, that's just a way of taking these rules and putting them in a way that my mind can make sense of them instead of having to look at the rule every single time. Now, if I solve these, it's I'm going to add 7 and add 7, so I get 3D is greater than 35, and then D is greater than 35 thirds. Just leave that alone. Then I'll add 7 here, add 7, so we get 3D is less than negative 14. So D then is less than negative 14 thirds. And again, I'll just leave that alone. I won't simplify those. I know that 35 thirds is to the right of negative 14 thirds. And this is saying D is greater than 35 thirds. So I'm going to have an open dot, and I'll shade to the right. And this is saying D is less than negative 14 thirds. So again, another open dot, and shade to the left. All right, in your homework tonight, there's going to be 1 or 2 questions that do something like this. Okay, I know we're not going to work all the way through this, but what is different between this and the rule that we said that said if absolute value of A is less than or equal to B? Okay, if I look at this, that side only has the absolute value on it, right? Does our problem, the left-hand side, have more than just the absolute value on it? Does that make sense to everybody? That plus 5 is throwing a wrench into things before I can actually do the rule. Okay? So what you need to do is you need to rewrite this as the absolute value of 2x minus 2 less than or equal to 8. And now that matches that. Does that make sense to everybody? Okay? So you need to, and everything we do, before you apply your rules that are provided for you, you need to make sure that your specific problem matches the rule, matches the if part. So in this case, it means you have to isolate the absolute value. Okay. Just a quick question before we get out of here. If let's say we have some expression 2x. Let's see here. Tell you what, let's not, because I don't think I gave you any in your homework like this. I'll talk about this either tomorrow or the next day. So don't worry about that next thing I was talking about.